Okay, class, we're going to continue on with a little bit of congruence. And just to recall what we've been doing, page 1 through 4 over here, worked a little bit about what congruence is. We learned there were some shortcuts that work, some of them don't, but our side, and side angle side do work. And this was the homework that I had talked through you. It says in there, homework, page 3 and 4, homework help, page 3 and 4. So hopefully you are to the point where you've gotten through with this. You can read given information and put markings on there, and you should be able to tell whether those two triangles can be proven congruent or not. And remember, there's only two ways that we can prove them congruent. It's side, and side angle side. And again, on these on page 4, you need to do all of the markings. Okay, so we're taking baby steps here, getting ready to do some proofs on page 5. So this is the setup. Let's do a few of these together. All right, it says that these segments are congruent. AD congruent to BC, and I've already marked this. That's AD congruent to BC, so I've got to read the given and put the markings. AD is also parallel to BC, so I'm going to have to put arrows on here. Just remember, when they say they're parallel, does not automatically mean they're congruent. All right, so both of those things are given. It says prove this triangle is congruent to that triangle. All right. So the next thing that I see right here that I'm thinking, when I have parallel lines, just to think of it this way for you, parallel lines, we always, give you a hint here, they're usually always alternate interior. So if these are the parallels, that means the alternate interiors are here and here. So if I mark it, I need to go and say it. So I'm going to say angle DAC is congruent to angle BCA. And the reason I know this is alternate interior angles are congruent when lines are parallel. We've been saying that. I just ran out of room. Okay. Alternate interior angles are congruent when lines are parallel. The next thing that we should all notice, we've talked a lot about having this shared piece in here. All right. So AC in this triangle is congruent to CA in the other triangle. It's shared. That is the reflexive property. It's congruent to itself. All right. So then that allows us to say, now I can take my proof statement. I know that's what I'm going to end with. So I'm proving that triangle ABC is congruent to triangle CDA. And my reason here is because of side angle side. Side angle side. You got to have it in both. Side angle side. Done. All right. There's a proof. Okay. Let's do another one together. This one's a little bit different. It deals with a few of our definitions from a previous unit. And that is something about isosceles and midpoint. But still, we know what happens to those. This is not hard. So if it says ABCD is isosceles, you write it down. And then I need to mark that. Okay, so what's the result of being isosceles? What was our definition of isosceles? Oh, yeah, at least two sides are congruent. So we're going to mark it like this. Okay, and then if I mark that, and I haven't said anything about it over here besides isosceles, I need to say that BA is congruent to BC. And the reason I know this is because that is the definition of isosceles. Something we learned as two sides congruent. The other thing is D is a midpoint. Well, if D is a midpoint, well, then that means I know that this side is equal to that side. So I'm going to say AD is congruent to CD. And my reason is I can say result of midpoint. And then the other item that I do know on here is that I always see that I have this shared piece right here. BD is congruent to itself, reflexive. And then my proof statement, I'm ready for it. Triangle ADB is congruent to triangle CDB because of side, side, side. All right. Hope you're cluing in on how to do these proofs. They're really not that difficult. Really, in your mind, on the other pages, you were doing the proof. You were answering the questions, but you just weren't formally writing it all out like this. All right. Let's look at one more. I'll get you started on this one. This one's an interesting one because this is one that has overlapping triangles. And so when you see this diagram like this, there's lots of triangles that we could prove that are congruent. But the ones that we're talking about are ADC, which is this one in blue right here, and CEA, which is I've highlighted in red, that runs from here to here to here. So here's the key thing, is I have pulled them apart and I have re-put the letters on there. All right. And so when you go to do this proof, don't try to do your markings on this original diagram. It will just mess you up, I promise. Okay. Because there's all kinds of markings you can get into. For example, some of you are going to say, well, I've got vertical angles right here, which is true. But that has nothing to do with those two triangles we're trying to prove. So don't chase, ghost right here and start trying to prove some other triangles are congruent when you don't need to. Just focus on the ones that you got. All right, and let's mark the given, because these were given information, but let's mark it down here. Don't mark it up there. So angle DAC is this angle. That's that one, is congruent to ECA. Okay, so that would have been a little hard for us to mark up here. That whole angle is equal to that whole angle. AD is congruent to CE, was also given, so that one was congruent to that one. All right, and then here's the part. This is a short proof, by the way. Here's the part that's a little bit of a reach for you. What else can I add to this? Those were the two givens, a pair of angles and a pair of sides. So what else can I add to this? I don't know if you see it yet, but they do share something. They share AC. And look at the letters right here, AC and AC. So this length down here, it's the same in this triangle as it is in that triangle. It just looks a little different than the ones up there than this, but it is the same idea. So I'm going to say that AC is congruent to AC, reflexive property. And then I'm ready to say the proof statement that triangle ADC is congruent to triangle CEA because I'll let you figure that out. I won't tell you the answer, but hopefully you can do that. That should be pretty easy, and that you can go ahead and do this problem.